So for today here, everybody, and this should finish up the rest of the chapter 4 assignment, and you should be able to do the rest of the numbers. So let me jump back here. This is what we did last. All right. So, and you can see up there highlighted the assignment. So um, anyway, I'll write that down here in a minute. But I just wanted to start back here real quick before I jump into the next thing. So we're still going to be talking about sequences here in 4.7. Okay. So I want to remind you of a couple things. So remember, for arithmetic sequences, we are adding or subtracting to get to the next number. That number that we are adding or subtracting by is called the common difference, right? That's right there. That is always represented by the variable d. Okay, so we're going to look at today how to write them. All right, so there's a couple equations that I'm going to show you for how to write an arithmetic sequence. You do not have to memorize these equations. I will give them to you when we have the test. Okay, but one thing I want you to see as well, and one thing I want to write down. So like this example that I did, the last one down here, that the common difference was -3 because we're subtracting by 3. So another thing that you'll see, like if we continue this, I put ... because this pattern just continues forever, right? So in math here, or in algebra, to represent what we're trying to find. Okay, so like if I just continue this pattern, I could keep going and find the 10th term, or the 20th term, or whatever term I wanted to find. Okay, the number, whatever number in the pattern that I wanted to find, or the term. We use that to represent, or we use this a of n. So it's kind of sort of like f of x. It's kind of like a function type of thing. A with the little n as a, I don't know if they call it a subscript or whatever. So that a of n stands for which term I want to find, because we're going to use those variables in our equations. So that's the big thing, is you don't necessarily have to memorize the equations because I'm going to give them to you, but we need to know what those variables stand for, right? Okay, so let's jump into this, writing arithmetic sequences, and we have two ways to do this. Okay, and these two ways are called recursive and explicit. Okay, there's a recursive way to write it and an explicit way to write it. Okay, we're going to talk about recursive first. Recursive works better just to find the next term as we go. All right, I'll be honest with you, out of the two ways, I like the other one better, and you'll see why once we get there. But recursive is if I want to find the next several terms of the sequence in a row, and here's the equation. Okay, and this equation is both of these parts. Okay, so here's what this means, and I'm going to label these things. So a of n, like I said, a of n, this first number here, I'm sorry, this first variable here, that stands for what we're trying to find. Okay, d, like I said up above, that's the common difference. Okay, so that'll stay consistent. Okay, so that's what are we going by? And you can see it says plus d, right? So if it's a positive number, if we're adding to get to our next number, then it would be plus whatever. But like the one right up above where the common difference is -3, then this would be a -3 there because that's a negative number. So it says plus there, but if it's negative, we can put minus, positive, we put plus. This right here, that stands for the previous term. Okay, that stands for the previous term. Okay, so what this equation is saying is that to find a of n, to find whatever I'm looking for, I'm going to plug in that number in for n and I have to find the previous term. So to find the third term, I would have to know the second term and then add the common difference. So this other thing under here, a of 1 stands for the 1 means the first term. That number there stands for the term that I want to find. So in order to write a recursive rule, I have to write down what the first term is. Otherwise, I can't do this. And then from there, all I can do is go in order. Okay, so it's kind of strange, like I said, using the recursive, but we're going to show you how to do it. So here's an example, because just this probably looks kind of like a jumbled mess right now. Okay, so just be patient. I know it looks funny, but we'll get through it. So let's look at our sequence here. -3 to -1 to 1, 3, 5. So what's happening is we are going up by 2, right? We're adding 2 every time, blah, 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 to get to our next term. So, once we find our common difference, we have everything that we need to write our equation. We have everything that we need. So here's what we're going to do. A of n equals a of n minus 1. And then what's our common difference is +2, so it'll be plus 2. And then what is a of 1? Or in other words, what's the first term of the sequence? The first term is -3. That's it. That's my equation for this one. Okay, I know the first term is -3. The plus 2 means I'm going up by 2 every time. Here's how to use it. So we have, what do we have? -3, -1, 1, 3, and 5. We have 1, 2, 3, 4. We have the first 5 terms listed there, correct? Okay, first term is -3, second term is -1, third term is 1, fourth term is 3, fifth term is 5. So if I wanted to find the sixth term, obviously I just had 2, but I want to show you how to use it in the equation. So the sixth term would be 7, right? We add 2 to 5 and get 7. But to use the equation to get that, if I want to find a of 6, oops, that was terrible. If I want to find a of 6, if I want to find the sixth term, here's what I do. I put 6 in for n, and then solve it. I put 6 in for n, and then I solve it. I guess I don't need that. I have that over there. Okay? So if I do that, a of 6 would equal 6 minus 1, of course, is 5. So a of 5 means what is the fifth term? Okay, what is the fifth term? Well, the fifth term is 5. So a of 6 would equal 5 plus 2. So a of 6, or the sixth term, is 7. Okay, so you can see how this one isn't super great, because if I asked you to find the 12th term or something like that, if I asked you to find the 12th term, if I asked you to find a of 12, when we plug that in, it would all be fine and great. A of 12 equals a of 11 plus 2. Well, that means I need to know what the 11th term is. So I'd have to go back up into my my sequence and add all of those numbers to get to the 11th term and then find it. So that's why this one isn't super great. Okay, and that's why it's not one I like a lot. But it's in there, and I wanted to show it to you, and it's something in algebra that we are kind of part of the things that we're asked to do. The explicit formula is much more useful and makes a lot more sense. So I'm going to focus more on that one, okay? But the explicit rule looks like this, okay? The explicit rule, the explicit formula. So it's a of 1 plus d times n minus 1. So you see some of the same things you just saw, right? A of 1 means the first term. D is still the common difference. Same thing as it was before. Okay, and then here we have an n. That's not a little n, that's a big. It's n minus 1. So n stands for the number of term you want to find. All right, so if I want to find the 12th term, like I said for the last one, if I want to find the 12th term, then I would just plug 12 in for n once I fill in the other stuff in my equation, okay? And again, like I said, I'm going to show you exactly how that works with this example. Sorry, I used a weird color. I don't know if it shows up very well, but all right, so the example here, I got the sequence. I have 12, 7, 2, -3, -8. Okay, so all we're going to do here is, what are we going by, right? How are we moving down? And we are subtracting 5, right? Every one of these is minus 5. And again, same thing here as the last one. Once I have that common difference of -5, I'm done. I don't need anything else. I can write the equation. So the explicit formula would be a of n equals, so a1, right, the first term, which is 12, first term of the sequence. Now it says plus d. Now this time the common difference is a -5, so I'm going to put minus 5 times n minus 1. This is it. That's the formula. Okay, so to find the numbers that go into the formula, go into the equation for this, is not very hard. All I got to do is find the common difference, and then I got to know what the first term is. That's it. Okay? And again, too, so from here, this is my equation for this, my explicit formula for my arithmetic sequence. If I want to find, let's do the 12th term. I keep saying 12th. Let's find a of 12. Let's find the 12th term. Okay, so in other words, what that means is I'm going to plug 12 in for n. Whoops. 12 in for n, and now all I got to do is solve this. And I'm done. Okay, so a of 12 would be 12 minus 5, and then 12 minus 1 is 11. And I'm going to do every little step just so you can see the numbers. 5 times 11 is 55. And then a of 12 equals 12 minus 55 is -43. So if you go back up there, we have only 5 terms again. If you would list them all out all the way into the 12th term would be -43. So I like this one better because whatever term I want to find, if I want to find the 50th term, all I got to do is plug 50 into my equation and I can find it and work it out instead of listing every single number all the way through. Okay, so these look like they're difficult and confusing, and I'm sure that they're going to be for the first part of it, but excuse me, come back to your notes, look at it. And once we know what those things stand for, those variables, first term and common difference and all that kind of junk, it becomes a little bit simpler to do. Okay, so I want to show you one more thing on this before I let you go and have you guys try to do the assignment on your own. So I'm going to write an explicit formula real quick. Let's say a of n equals -9 plus 4 times n minus 1. So this would be explicit. This would be an explicit rule or formula. All right, and if we look back, I'm not going to go back up, but if I would look back at the formula, look back what I wrote, and actually let me do that. Those numbers represent those different things. So the first number in the equation is what? That's the first term. So here, -9 is the first term of my sequence. So if I would try to write this sequence out, I know it's going to be -9 is my first number. 4, that tells me what the common difference is, and it's a positive 4. So I know that the common difference is plus 4. So from here, I could go and start writing out my sequence. Just keep adding 4, right? Okay, if I wanted to, or I could use the equation that they give me. But that's what those means. They can kind of work both directions there in both ways, where we can give the sequence and then write the equation ourselves, or we could be given the equation and then write the sequence from there. Okay? And if I wanted to, and I think they may have asked you to do this in the assignment, here's an explicit formula that they give us. Let's write the recursive. So the recursive formula, if we go back up to that, where'd that go? There it is. Recursive formula way up there is a of n equals a of n minus 1 plus d, and then we have to list the first term. Well, we know the first term is -9, right? We just talked about that a second ago. And then now, we also know that what the common difference is 4. So there's the recursive rule. So you can write these, you can go between all three of these pretty quickly just by knowing what's the first term and what's the common difference. You're going to need to look back at the equations a lot, and like I said, that's fine. You don't want to memorize them anyway. I'll put them on the tests and stuff when we have them. Okay? All right. So this should then, up here, and I'm not even going to put it up here, the numbers, you can do the rest. Okay? So that would be like number 46, and then what was it? Like 53 to 60. I guess I should write it. So now we can do 46 and then 53 through 60. Okay, in other words, we are done with the notes for chapter 4. You can finish up everything. Okay, all right. Let me know if you need any help. Good luck.